everybody. I'm Matt Hatton, founding partner at Transforma Insights. We're a industry analyst firm focused predominantly on the Internet of Things. One of the things that we get to see at the Things Conference is new products and new developments in the industry. And one of those new developments that we're going to be talking about today is Modem-E, and specifically the early adopter experience with Modem-E. If you're not familiar, these folks are much more knowledgeable about the topic than me, but effectively it's putting full LoRaWAN stack onto the chipset rather than needing to have separately the LoRaWAN stack on the microprocessor. So certain significant advantages and opportunities associated with that. I should let my panel introduce themselves. I will start at this end. Fabio, if you'd like to introduce yourself and say a little bit about who you are and what you do.
Sure. Hi, Matt. I'm Fabio Bonizzi. I'm the CEO of Embit. Embit is a design house and module manufacturer. We are based in Italy, and we are a Semtech partner. We work on several protocols, starting from LoRa and LoRaWAN, and we produce a micro-open platform where customer can develop their own application. So we were part of this beta program to test ModemE on our solutions.
Excellent, and more on that in a moment.
Yeah.
And Carlo.
Yeah, thanks, Matt, for the introduction. So I'm Carlo Tinella. I'm product marketing manager of LoRa catalog in Semtech since 5 years. I don't think we need to introduce Semtech. But yeah, just I would like to say that I moved into this role after more than 20 years in a pure engineering career as a RFIC and analog design.
And Suman.
Thank you, Matt. I'm Suman Thapa, Senior Product Engineer for LPWA modules at Murata Electronics, and I'm based in Murata, France office. So about Murata, we are mainly from the MLCC and the component business, but over the couple of decades, we have expanded our lineups to the module manufacturing, including the module which features the chipset from Semtech. And I'm responsible for the product management and the product marketing in the EMEA region.
Excellent. And Carlo, I'm coming to you first, just to explain for anybody who's in the audience or watching this on catch-up later. Can you give a little introduction to Modem-E and some of the technical implementations and the value proposition associated with that?
Great. I would be very glad, because actually I feel it as a little baby of my, let's say, mission in Semtech to define roadmaps and new products. Matt, you summarized very well in a very few words what ModemE is. It's the implementation of the LoRaWAN stack that is now capable to run into one of our chips, namely the LRM21. But now, the reason why we introduced this is because we are seeing a kind of urgent call to action from our ecosystem about simplifying and shortening their development cycle and the risk associated to development. Okay, so we took the decision to take advantage of the digital processing power that is implemented into the LR11 family in order to implement a single SKU LoRaWAN stack. So now customer can grab it from our GitHub repository, LoRaNet. I invite you to have a look at it, and flash it on the LR21. And they will get a full LoRaWAN stack, full LoRaWAN certified stack for all the regions. So one of our goals is to provide a single SKU LoRaWAN stack. No need for a customer to deal with the burden of integrating the LoRaWAN stack on their microcontroller host with their application code, with other kind of connectivities, and dealing with the complexity of this integration. Maybe not only a bare metal with some sort of RTOS, real-time operating system. So now this complexity is removed from the shoulders of our customers and took to the into the LR1121. Okay, so really simplifying, narrowing the development cycle of the customers, which at the end gives them the advantage of quicker go-to-market. Then the other reason that motivated us into this project is to really provide some sort of monetization, direct monetization to our customers. Why that? Because now with the possibility to take the stack and run it into the 1121, we are freeing processing power into the microcontroller, the host microcontroller. And this processing power can be leveraged on two axes of freedom. One is squeezing the memory footprint, which at the end turns into cost, or using this memory to run a more complex application, more intelligence at the edge. So really serving also this powerful trend that we are seeing of integrating more and more intelligence at the edge, but with a minimal cost budget in terms of BOM. So that's what really is the essence of ModemE.
Okay, so you're simplifying the integration process. You're freeing up space on the microcontroller that might be used for something else or might be squeezed out to reduce cost. What about power consumption? Is that another factor to consider?
Good point. Thanks, Matt, for raising this. So now the possibility to run the LoRaWAN stack in a self-contained way into the 1121 opens also the possibility to save power for all those use cases where there is a intensive use of Class B, for instance, during the FOTA sessions. Because now there is no need anymore to wake up the host microcontroller for each RX window that is open for the Class B. And the external microcontroller will be only waked up when there is a real packet that has been received by the LR1121 during the FOTA session, for instance. But this is a general, let's say, statement that we can say for all those use cases that are needing Class B. So indeed, there is a power consumption saving related to the ModemE for use cases where Class B is a kind of frequent feature or that must be used.
Excellent.
Great.
And Suman, I'd like to come to you. You have your Type 2 GT module, if I remember rightly, making use of Modem-E. Why did you decide to use it? Why did you decide to develop that product?
Yes, it's a very good question. So actually, over the last decades, so Murata is in this LoRaWAN ecosystem almost from the beginning and the formation of the LoRa Alliance. So when we started to step into this LoRaWAN, then we decided to make a module like OpenMCU platform. So with OpenMCU platform, it means you have one microcontroller and the LoRa transceiver together inside the package. So we were developing a multiple series of this kind of product. But over the recent year, there were some kind of customer group who were overcoming, or we were finding different kind of challenges. So challenges like they needed some kind of certified LoRaWAN modem because they didn't want to manage the LoRaWAN stack. And some of the customer, they already had the host MCU, which means they don't want to use the microcontroller that is provided by Murata inside our module. And some wanted to have dual protocol stack, and they wanted one SKU. And also recently what we see a new trend is many of the device maker, they released their device using the generation 1 and generation 2 chipset from Semtech, but now they want to have generation 3 product in the market, but they wanted to quickly launch their product in the market, minimizing their development length, cycle and cost. So to tackle this kind of things, we decided to cooperate together with Semtech and provide them one solution which provides them in flexibility and MCU selection, cost-effective solution so that they can scale, and also ease of integration, both in hardware and in software.
So you mentioned a couple of other additional benefits associated there, which is time to market and also cost. So how do you measure time to market and cost benefits, or have you got an idea, an indication of what the kind of time to market savings might be, or cost implications might be?
Yes. So Type 2 GT modem is fully committed to reduce the development cost and eliminating the design complexities. And this is done through cost efficiency, simplicity, and flexibility. So when we talk about the cost efficiency, so using this kind of module solution, end device maker will be able to go through fewer and simpler production steps, which means they can reduce their production cost. And also the Modem-E already includes the LoRaWAN stack, which means end customer, they will be able to use lower footprint, low cost MCU to host only their application part. And when you talk about the simplicity, this kind of module already integrates majority of the customer that is required to make an end node sensor. It means on the final PCB of the customer, there will be very fewer components required, which means for the developer, they can quickly do their prototyping, and also their PCB size can be increased, which means at the end you will save some cost. And when it comes to flexibility, this Type 2 GT module really stands out, because if you are used to with an existing microcontroller, then if I offer you something else, then it will take time for the developer to get used to with the new environment. But with this Type 2 GT ModemE solution, the customer can stay with their existing ecosystem, and then they can develop their application firmware, focusing only on the application and reducing the time to market even on the software development.
Okay, and that, you mentioned there's quite a significant number of values to the end customer. Is there anything else that you see as being particularly of value to end customers?
So end customer, one of the value is they don't have to think about the managing the complex LoRaWAN stack. Second is this kind of module, we have already obtained regulatory certificates for US, EU, Canada, and Japan market. So, and also this module is, it supports connectivity in 2.4 gigahertz and sub-gigahertz band. And all this kind of feature, if we compile together, then for device maker, it means simplified device design, time to market, etc.
And so do you find that opens up new potential customers then?
I truly believe, because while we were, let's say, providing the open MCU platform, what we did was also, we also provided the UART-based LoRaWAN modem. So there were some kind of customer group who always needed LoRaWAN modem. So let's say majority of the customer, they wanted open MCU, but there were some customer who always needed modem solution. And the existing UART-based modem module, so this kind of solution were little bit expensive if we compare with this kind of Type 2 GT ModemE. But now this kind of customer group, they are more and more interested towards adopting Type 2 GT ModemE.
Excellent stuff. Thank you. Fabio, I'd like to turn to you now. How are you using the new ModemE within your products?
It seems that we work on the same company, because benefits.
What that guy said. Yeah.
No, I'm totally aligned with you. We decided to implement this solution, even if we have a LoRaWAN stack. We are the owner of all our LoRaWAN stack. And since we deploy micro-embedded devices, so all our modules have been designed to be open for customers. So customer can deploy, can develop their own application directly on the microcontroller part of the module. We thought that ModemE was an opportunity to make, to deploy a very simple, scalable, and low-cost solution. Since the stack is embedded on the transceiver, we decided to configure the module with a simple but low power and very interesting platform based on STM portfolio. So STM microcontroller from it's a Cortex M0 Plus, where customer can choose different size of RAM and flash configuration. So the microcontroller has been thought to be used just to develop an application from the customer that maybe can use a simple sensor directly connected to the modem. So one of the added value is that the stack, so the LoRaWAN stack is in an independent area, completely an independent and secure area, where a customer that is going to develop his own application do not touch it. So it's safe, it's completely independent, and he is going to focus directly on the microcontroller instead of using the same single chip, the same platform where LoRaWAN and the application should coexist.
Okay, so that's a simplification of the application or device development process, which is something we haven't necessarily talked
Obviously,
about.
the time to market for us to deploy a new solution has been an added value, because we have a solution that has been validated, certified, and stressed from Semtech. We have the stack. We are the owner of the LoRaWAN stack, but in case of every time we design a new platform, we have to tune the stack accordingly with the new transceiver. We have to stress it, to validate, to certify it. So also in terms of time to market for us as a manufacturer, it's a absolutely good choice.
Okay, and what would be the advantages of using the Embit module that's making use of ModemE rather than any other?
I think that's what more or less I share with you. You have a solution that should be an open micro-embedded solution, but also it should be a modem, so a black box. Since the stack is in the transceiver, the microcontroller can be configured as a very simple and low-cost solution, because our STM has up to 40 kilobytes of RAM and 256 kilobytes of flash. So, but it starts with a very low configuration. So, in terms of RAM and flash, so it's very simple, and in this case, is in the hands of the customer to configure the solution. Moreover, the product roadmap for Ambit start with providing a solution based on ModemE, but since the microcontroller is scalable, we are going to offer additional feature, adding a new protocol like wireless and bus. We are the owner also of wireless and bus that is huge for telemetry in the gas and water. And so the solution will be a dual stack. From one side, fully compliant LoRaWAN, on the other side, wireless and bus for the metering scenario. Finally, it will include also a proprietary device-to-device stack, where customer can, let me say, set up a very simple network in a point-to-point and peer-to-peer way. So in order to reduce the latency. So it's a very scalable solution and very, I think, clever platform, thanks to the independent scenario of a ModemE and the transceiver.
I noted with the new product that there's two RF ports, one for sub-gigahertz and one for 2.4 gigahertz. What's the, this isn't necessarily a question about ModemE, but what was the thinking about including both of those sets of bands?
Yeah, thanks for this question, because it's interesting also to share that probably not all the customers know that LoRaWAN and LoRa is not only sub 1 gigahertz. LoRa exists on 868 and 915, but also on 2.4 gigahertz. And we have a complete 2.4 LoRa suite with module, mini PCI Express, and gateways that are capable to work more or less on the same way as LoRaWAN, even if it's not fully, let me say, formally LoRaWAN 2.4. It's called LoRa 2.4, and it works with the same benefit and same approach of LoRa. In this case, we decided to provide a multi-frequency solution. So thanks to the latest transceiver, the LR1121 from Semtech, that works on both, the module can be set as sub-1 GHz LoRaWAN or LoRa 2.4. And this is huge because on LoRa we don't have any limit. On LoRa 2.4 we don't have any limit in terms of duty cycle. It's a worldwide solution because it can be shipped all over the world with a single, let me say, frequency. And it has also the benefit of a bandwidth that sometimes helps to transfer data, compare obviously with the A68.
Excellent. So, Carlo, I'm going to come back to you. We've heard a couple of examples here of companies that have made use of the Modem-E. What are other device developers who might be interested in this? What do they need to be aware of? What's the availability of the chips? What are some of the practicalities around that?
I mean, ModemE is not only, so today we have the representation of module makers that they've been eager to get started with ModemE since the beginning. They were very enthusiastic about this idea. But ModemE is not only addressing the market that prefers to source modules, okay? It's also something that can serve very efficiently all other customers that prefer, for whatever reason, prefer to go chip down, meaning they prefer to integrate and design their own wireless module, okay? Also for those guys, especially for those guys, ModemE simplifies a lot the development cycle. So we have been talking about, so Fabio mentioned the possibility to really keep apart the stack from the application code, okay? Suman mentioned, okay, it's really a full, let's say, self-consistent solution that is offered. But indeed, when somebody starts to develop the firmware, if this firmware must contain a stack, which is a commodity at the end, okay? It's not where the value of the customer is. The intelligence is in the application code, okay? But when a customer has to deal with a firmware that has his own intelligence plus the stack, each time he has to, let's say, finds a bug and he has to fix it, he must do a re-validation of the stack because the firmware is a kind of monolithic block, okay? With that, we are really simplifying also the validation. They don't have to run all the validation of the LoRa stack. And that's valid for everyone, for the module makers, but also for the customer that prefers to go chip down. So basically, it's very horizontal serving our customer base.
Excellent. I think that's a good place to leave it. A very valuable additional tool in the LoRaWAN armory. Let's put it that way. Gentlemen, thank you for your contributions there. A fascinating discussion on a very specific part of LoRaWAN. So thank you very much, and thank you all for your attention.
Thanks to you, Mark.
Thank you, everyone.